Okay, it is trying to index. Hey guys, first let me delete existing stream because that's unnecessary. Live, I'll see it. Manage. Okay, leave it. I'll drop it later. Just let me see if my stream is perfect, and then we start with the introduction first. Okay, my bad. Instead of it, yeah. So it's working. I hope I'm audible or not. Bro, can you speak? First, let me. Yeah. Okay, it is working, bro. Is there network issue or what? Speed test. Bravo. Yeah, it's perfect. My OMG, we are getting good speed. At least download speed is good. I don't know about upload. Let's see. Okay. Yeah, it's perfect. We can stream it right now. Hey guys, so welcome to the channel, and my name is Ramu. Okay. Uh, that doesn't matter. So we are on the day 11, and if you remember yesterday I just tried to solve two problems and stuck into second problem, and after that, to be honest, I was busy in other stuff, and kind of busy, but I can learn them. I mean, yes, so it's my mistake, like I haven't attempted the case question again, and today I have to revisit the same, so it's like I'm making same mistakes again and again, so that's not acceptable here. And so let's begin. So it's day 11 of learning DSA, and we have made so much pretty much good progress. So let me jump to the take you forward, and we'll go through the you can say array. We have started learning array, and if you see, we are trying to solve hard problems and merge overlapping subintervals. Did I solve it, or just? Oh, okay. So we were solving this one. Merge overlapping, we covered it, and now merge to sorted arrays. So I think we need to start from. Yeah. So we were thinking like we will solve like this, but after that I felt like I won't be able to attempt it, or maybe it will take time. Let's see if I came up with a new tutorial. I mean, definitely we need to solve it anyhow. So I'll go through the tutorial first, so that my motivation or my moral won't be down. So let me see the tutorial for second. Use two-pointer approach to merge two arrays in place for the most optimized solution. Assume the two arrays are as a single continuous array, and initially as the ask is to merge both array into one array. Eventually will be placed left pointer at the first index and right pointer at the you can say left plus gap index of the continuous array. Now we'll compare element at both the pointer, and if array of left is greater than the array of right, we'll swap as we want to merge array in non-decreasing order. After each iteration, update the gap value. It will ensure to merge the two arrays without using extra space. To be honest, I did not get it. Use two pointer approach to merge two arrays in place. Okay, for the most optimized solution, assume the two arrays as a single continuous array, and initially as the ask is to merge the arrays in one array eventually. We'll place the left pointer at the first index and the right pointer at the left plus gap index of the continuous array. Okay, left plus gap. Okay, left plus gap means at the end of array, you can say. No, I mean it will be in between somewhere. Now we'll compare if array of left is greater than array of right. Definitely, but if you are applying it in sorted array, 1 minute. Size of array 1 plus size of array 2 by 2. Okay. Disordered, the largest element is merged in the merged array must come from the end of one of the two arrays. Okay, and from the back and placing the larger one at the last available position. The merging can be done efficiently without using extra space. Repeating this step ensures that all the positions are filled in the correct order, ultimately producing a fully sorted array within the first array itself. How is it possible to okay -5 -2 4 5. Oh, alright. Quick time player. Okay, let me just add it. New movie recording. Oh, my bad. Why are you not working, bro? Quick time player. Something went wrong or what? I think now it will work. Yeah. So here we have. So let me note down the numbers. So can I say I have a number 5 minus 2 and 4 5, and another array is -3 1 and 8. Now what we will do, so will be having total, you can say -5 -2 4 5 0 0 0. Now these two, let's say, begin. This is an array and this is another array. At starting, I will be here and J will be here. And now check which one is bigger number. So you can see this number is bigger. No, yeah, so 8 is bigger than the all number. So can I say we'll place 8 here. Now we'll move to this number and we'll say 1 or 5. So 5 will be here. Now we have 4. So this one will be removed, or space will be here. So 4 will be here. Now 4 or -3. If this one will go, then here will be space. If this one will come, oh great, this approach is correct one, I believe, the best approach. -3 will come here. No, so 4 will come here. Now -2 -3. So I know -2 is greater than the -3. So -2 will come here and spaces are going upwards. So okay, wow, so this approach is perfect one. So let me solve using this only. Optimal 3, optimal 2 will consider later. So I got it, but why I did not think about it. I was trying to solve it, but it was a complex problem. Like, I mean, I was trying to solve it from another angle, and it was a complex problem, to be honest, complex approach. But I think we can. So let me do it. So start, not to start. Okay, we have m and n both, right? So I will be m and m minus 1, j will be n minus 1. Okay, great. Now we need to start scanning the numbers until while I greater than equals to 0 and j greater than equals to, or no, we need to use and j greater than equals to 0. You know, once one will be finished, then yeah, or even we don't need to say like I greater than equals to 0, because if something is coming from the I, then definitely it will be in the within the array. If something is remaining, that means all the elements of j are filled. So if okay, so what I'm thinking, like if something is coming from I, either it will be placed. So if, okay, let me think more about it. What can be corner cases? I feel like I'm just missing something. So should I assume like I greater than equals to 0 will be enough, or I need to check j, not I need to check I greater than equals to 0 and j greater than equals to 0, or just j greater than equals to 0 will be sufficient. If j is greater than or equals to 0, that means there are some elements, so we need to fill them into this array. So until j will be finished, but what if there are some elements remaining in this one? So this is a sorted array, right? And whenever we are going to process it, if something is remaining here, that means all the other elements are being placed to their original location, and all the remaining elements are sorted. So we can say like, yeah, while j greater than equals to 0, then we can say if you can say nums of 1 of I is greater than nums of 2 of j, nums of 1 greater than this, then you can say, and let's say k equals to nothing but the length of m plus n minus 1. So yeah, that will be the index. So it will be, that means we are going to swipe this number, or we are going to exchange this number to shift to. So we'll be having a space at this location. Yes, so nums of 1 of, okay, so nums of 1 of k will be having nums of 1 of what, I. So we are migrating or transferring I to this location, and now we need to change k plus equals to 1 not 1, minus equals to 1, because we have filled the last element, last index, and now we need to check I. So I will be I plus equals to 1. I mean, no, I minus equals to 1. Sorry, my bad. And now we have covered this. Else, that means this number is not greater than, so we can there could be two scenarios. This number is equal to this number, or this number is num2 is smaller, so we need to transfer that number. So nums, you can say nums of 1 of, not my bad, nums 1 of k will be nums2 of j, and now we need to update j minus equals to 1, and I, we have to update it as well. No, we don't need to update I, but we need to change k minus equals to 1, and finally whatever we are getting return, you can say nums1. So this approach is very simple and easy peasy, but my bad, I made any mistake or what? What the heck happened? If nums1 greater than nums2 of, say, nums1, I will be if nums1, okay, line 16, what went wrong, bro? List index out of range. J equals to n minus 1. IJR is starting with 3, so 3 and 2, 1 2 3 4 3 1 2 2 1 1 0 1. Man, I really did something fishy. 0278. Okay, we need to change a little condition. I mean, there are some scenarios that needs repeating the same process again. It feels like I made a mistake that needs to be addressed now. So there are two scenarios. First one is okay, j greater than 0 equals to 0. That is true. Until j is not finished, we need to process it. But what we have swapped all the numbers of I that are smaller than starting element of j. So that means all the numbers of I will be migrated. Then we have j. Then what needs to be done? Simply start plucking the number from there and start putting them. So if I mean I is already finished, that means I is you can say less than 0. Okay, that means we have covered all the I. Then we do not need to compare anything. Yeah, so that's what. So greater than equals to 0 and greater than equals to 0, then that means we need to use this condition. Otherwise it will be like nums1 k just start and j minus minus. Try now and everything will work. And for sure I'm telling you surety after submitting it. And sorry for the, so we solved it, but definitely I'll make a note on it because this problem is, let me add a, first I'll add a star here because this problem is really great. I need, you need to think out of box. To be honest, I wasn't able to think. Let me note down. You have to think, and I need to go through the another solution. I think out of a box and wasn't able to solve it, though I thought a solution but couldn't implement it. Failed to implement it. Okay, so that's how we are going to keep a note on it, so that because it's not like once we covered all the problems, it's then from my end there will be. So let's jump to the another straightly, like let's straight jump to the another problem so that we can solve at least one more problem other than this. So I'm targeting 2 problems a day at least. So if you are taking 2 hours of time, then you should solve 2 problems. So without wasting time, let's jump to the problem. If it is easy, then we'll finish it quickly, otherwise we'll have to take time. Longest consecutive sequence in an array. So I have noticed these kinds of problem always we see in the like in interviews, or it could be in you can say in a assessment. When they are providing any assessment, then definitely there will be these kinds of problems, longest, and I always feel like these are the problems that I won't be able to solve. And now we need to change that perception, and let's understand it from in a deeper way. So let me assign it 45 minutes of time. I'm assuming like I'll take little more time. So 45 minutes, let's target it. Given an array of nums of n integers. Okay, great. Return the length of the longest sequence of consecutive integers. Okay, length of longest sequence of consecutive integers. Okay, return the length of longest sequence of consecutive integers. The integer in the sequence can appear in any order. The integer in a sequence can appear in any order. Okay, so maybe you can say consecutive, this would be consecutive. So 104, 200, 132. Consecutive, the numbers should be consecutive. I mean 1, 2, 3, 4, but it can be anywhere and in any order. 4, 1, 3, 2. Wow. So it's like the difference between the numbers should be 1, but they can appear in any order. I know one option would be to sort the numbers so that they will place all the consecutive will be in a single place, but that's not an approach that we are going to use. That will be kind of brute force approach, and we do not expect that solution while solving. So for like if you are going to tell it to interviewer, then definitely you can consider that solution while telling about the brute force approach. But after that, like, you have to come up with a solution that is more efficient and the longest sequence of consecutive elements. And if we, let's say, 0 and 1, 0 1 2 3 4 5 6 7 8, so it's like 0 to 8, we have all the numbers consecutively. So yeah, so that is the longest sequence, we can say. Now this problem is a good one. I mean, I don't know how to solve it, but we are here to know it, to hustle and derive the things. Instead of just saying no, we'll say yes, we'll do it. 0 3 7 2 5 and then 8, then 4 6 0 1, 4 6 and 0 and 1. So these are the numbers that we have right now. So this is input 1. I mean, let me use some highlight color. So input 1, and this is IP input 2. So these are the numbers. Great. Now we need to jump to solution. Not solution. We need to think about it, how we are going to solve this problem. So option 1, what I can think of, sort and traverse. Then simply you need to check if the number is, for example, if you are starting, the sorting value will be 1 2 3 and 4, then 100 and then 200. So these are the numbers. Now you just need to scan from the starting. So you will say 1, okay, this is the highest sequence. So count would be equals to 1, and okay, now you will go to this number and you see it is greater than the previous number, so we can say count will be 2 and result will be 2. So far we have the max number this. Now we'll jump to this number and it is greater than this number, so can we say count equals to 3. Then we'll jump to this number and can see we say count equals to 4. After that, this will see this number. This number is not the you can say the continuation of second past number, so we can say count equals will be 1. And then we are going to move to this number, so we will say okay, it's not. Then we will be having this number as a max number and no one is able to upgrade this number, so no one is able to beat this number. Here also 0 1 2 3 4 5 6. My bad, I wrote. So now we have number 0. Okay, 0 will be 2 times, so can we say like 0? If we are seeing 0 0, that means it's not a continuous, so count will be 1, and again it will be count will be 1. So okay, now 1 will come here, then 2 will come, 3 come, 4 5 6 7 and then 8. Okay, great. So we have numbers like 2 to 4 to 6 to 8. So we have the longest consecutive sequence of numbers as a 9 numbers. Okay, here. But the problem is if we'll go for sorting, it will be n log n. And I'm just thinking about it. Though we have number like that we can accommodate, I mean, based on the constraints, we can say like we can use this algorithm, but problem is we are looking for something that is smarter and shorter, or maybe it will take lesser time. So can we change it to order of log n instead of order of log n log n? One 3 10 4 22 1 3 10 4 22 9 1 9 1 2 3 4, so 4 will be okay. Great. I think I am not sharing my screen or what. Let me take down the example first. 100 4 4 200 1 3 3 2 100 4 200 1 3 and 2. So these are the numbers. Without sorting, how can we solve it? Can we or not? Two numbers, when they will be consecutive? Okay, so if we assume like we are starting as it is, 100 will be 100. Okay, so here without sorting, can we solve it or not? Return the length of longest sequence of consecutive integers. Integers in the sequence can appear in an order. No, it's not possible or what? One hundred. First thing, can we solve it without sorting? I'm confused about it. Let me see how many options are there. Better, optimal. Then finding the longest consecution using simple iteration. Better approach. Bro, this is what I'm assuming. What there is optimal solution, that I don't know. So just try to see it. Uh, because I always feel like why I haven't thought about it, or why did not get I some science kind of clue about it. Why I always think so. These types of questions. Now just I'm assuming how we will solve it. If there is solution, then what is the reason I am unable to get the pattern? 104, 200, 132. That means these numbers are going to be 100. Okay. One, two, three, four. Can we use hash map? I mean, we'll store all the numbers 100. If we have a 101, that means we can consider 100 and 101. Then I forgot, sorry. 104, 200, 132. These are the numbers. Now, what could be the solution here? I don't think this one will be the same as sorting number. Okay. It is not coming into my mind or what? 104, 200, 132. Okay. I mean, literally. So, 104, 200, 132, and here I am clueless. Hot, accept the sort and process. I need a smart approach. 104, 200, 132. So 2, can we do it? No, I'm not getting a solution for it. Let me see if I can solve it using hint only. We do not have hint. First, all elements are placed into set data structure. Initialization 2 3 2 3 100 1 1 100 4 102. That's it. Okay. Count to 1 indicating the starting element of the new sequence. Okay. I'm not getting it. Hasting optimal approach, largest con. I mean, yeah, I feel this one is a problem where I'm feeling stuck, or I mean, I need to think more, then only I'll be able to get it. In this approach, we refine the brute force method for focusing only on potential starting number of sequence rather than searching for sequence for every array element. This targeted strategy enhances efficiency using a set data structure. And longest to store the maximum length found. Okay, great. First, all array elements are placed into a set data structure. Okay, okay, great. So based on this, they are saying we need to create a set Great. So in set we can search in order of 1. We can find an element. So we'll fill everything in this set. Now we need to check potential starting element. So an element can be starting element if does not have previous continuous element. That means it can be starting element. So if x minus 1 not in set, then it can be. Okay, great. Now we have the sequence of numbers. You can say we have numbers like 100 and 4, 200, 1, 3, 2. These are the numbers. Now we'll start looking for 100 for the numbers that can be sequence. So first we'll see 100. Is there 100 minus 2? First let's see what are the potential elements that can be. So can 2 be 2 minus 1? No, it can't be. 2 can't be. So let me say 2 can't be. Then can we say 3? 3 minus 2, 1, 2. So 3 can't be. 1 minus 0, yes 1 can be. Okay, 200 can be. 4 minus 1, 3. No, 4 can't be. And 100 can be. So we'll start with 1. So we'll say, is there 1 plus 1? 1 count will be 1. Then we'll say 1 plus 1 is there. So yeah, it's there. Then count 2. Then we'll say 1 plus 1, 2 plus 1, 3. Yes, there is. Then 3, count 4, and then we'll start for 200. Okay, so for a element, what could be? So first thing is order of n will be the time, as we are going to iterate through all the elements, and we need to check if can an element be. Then for each element, you can say the elements that will be the continuous. So complexity order of n plus order of 2n. I'll went into the set data structure. After that, for every starting element we find the consecutive elements. Although nested loops are used, the set will be traversed at most twice in the worst case. Why the set will be log n, resulting into a total time complexity of n log n. The total time complexity would be approximately if we use set instead of unordered set. The set operations will have a time complexity of order of n. The total time complexity would be okay. Why 2n we are saying? So each element will be, they are saying at most twice element can be traversed. When? First, when we are checking the numbers in an array, if the number is not the sequence of it, then we are discarding it. If the number is, then we are considering it, but that means it does not contain, it's not part of anything. So 1, it will be okay. And then second element, definitely I need to okay. So what I'm thinking, how I'm going to justify it, like it will take 2 order of 2n, and the reason for that is, like, for example, let's take, so we will start scanning from each element. That means if everything is going well, it will take order of n. If nothing is matching or there isn't any starting element, right? That means we have traversed array once. But another condition would be, suppose we traversed and there is only one element, and that is going to cause that will be like, now you are using 1, then 1 plus 1, 1 plus 2, 1 plus 3, and so on. So that means you are going to revisit every element again. That's why order of 2n. I am assuming it, not assume. Oh my bad, what went wrong? Solve it on paper. Okay, let me jump to the solution. First let me see how can we, okay, so this solution, I know second one, I thought like we need to do something. So unordered set in Python. Add or discard, okay. So we have 14 minutes, bro, but yeah, I took the help of the solution. So yeah, that's okay. Sometimes like we don't know. I know one approach, but second one was very difficult to get it or to. But why? I mean, literally, I don't know. So let me use set, or let's say s is nothing but set of set, and now let's start building or inserting elements into set. So for el in nums s dot add el, so we added numbers. Now the next step would be, okay, great. So now the next step would be okay, what just counting now. Yeah, so elements we have added, and next step is just we have to start scanning for the elements that can be potential for starting element. So for EL in you can say, well, again you said what is this, bro? Can you be little fluent, more fluent? Yeah, let me try. Don't be rude. EL in nums, and okay, great. So we are again iterating. If EL, okay, let me I have doubt. So how to Python terminal, okay, sometimes Python 3, here we have to use 3. Okay, s is nothing but set s dot add 1 and s dot add 2, and now say 1 in s, wow, my bad, true, 5 in yes, false. So in operator is using for the check. If EL in EL minus 1 in s, that means this element, that means can't be starting element. Okay, so just say continue. Yeah, else it could be, and let me start again. So yeah, now we'll say like while EL while true, that means so if EL, okay, so we say CNT equals to 0, and okay, let me just take, so we are just start equals to EL, and now we'll just say now we have one element count in sequence, and while true means while true it's going to iterate. So if EL plus 1 start plus 1 in EL in S, that means this element exists. So count plus equals to 1 and start plus equals to 1, that means we are just appending, that means this number is there, and else break the loop. Now we got the count, and we can say max will be, currently we have 0, and okay, my bad, I can't use largest, okay, this is, and count. So you can say largest is nothing but max of largest and count. So yeah, so finally we get it. While true break, we got this loop and this one else part. So I hope it's okay. Now let me just directly do the one thing, but yeah, it's a kind of where you have where there are trade-offs between, like whether it could be order of 2n and it can go up to order of 1n square in worst case when set is taking time of order of n, but that is worst case scenario. I mean rare in the rarest in the rare, no rare in the rarest or rarest in the rare. Yeah, so return the number or return what, largest. Let's try it, but definitely I need to revisit this problem. I definitely need to revisit, because this is where I just have, like, in my mind I got one solution only, approach, and yeah, so longest consecutive sequence in array. So let me say some note. Let me write. I was able to think of a solution using sorting, but wasn't able to think of using set. So expecting next time to know both approach. Okay, so we have written the notes. Now we need to attempt this one. Longest, why it is showing this? Longest subarray with given some k positive. Subarray, continuous array. So many things are there. Given an array nums of size n and an integer k, find the length of longest subarray that sums to k. If no such subarray exists, return 0. Okay, so first thing is we need to look for an array where we can like sum of a subarray, I mean where the elements of an array can be, you can say this, if we are adding up all the elements, then it's the sum is equals to target. Great. Now there could be multiple options, then you have to look for the one having larger number of elements. Okay, so we have 10, 5, 2, 7, 1, 9, 15. So I know one could be 9, 1, 5. The another one could be, okay, okay, 1, 7, 8 and 1, 2, 3, 7, 10, 5. 1 and 2, 3, 7, 10 plus 5, 15. 9, 1, 10, 7. Okay, no. Okay, this is a good question, and how I will approach it. Okay, great. So these are the problems where I always feel like I won't be able to solve, or maybe I do not know the patterns of these problems, how to approach. So always I get scared of these problems, and that's where the problem arrives. So let me note down first. 10 we have 5, we have 2, we have 7, we have 1, we have 9, and great, and target is 15. And another question will be, we have -3, 2, 1, and k is 6. So let's say, can we solve it without order sorting? Do we need sorting? I don't think. Let me see it. We need 15. So let's say if I'm taking this number, so what will be the case? we have 10. Okay, can I get 10? We just reduced it by 10, so we need 5. So do we have 5? So 10 comma 5 will be one solution. Now we added 10. Can we have okay, what I'm thinking, first let's analyze it. So we need to get into brute force approaches. So first we have 10. Let me see if we can get it uh, with the different numbers. How can we approach it? Suppose I am considering 5. Okay, 10 plus 5, we have 15. Now can I make more numbers? I mean, can I? No. So can I check with this number? 10 plus 2, 12, and 12 plus 7, we can't do it. 12 plus 1, okay, 13, and 13 plus 9, it will be more. So can I say like it won't be possible with these numbers? Then let's jump to this number. That means we tried to check if it could be part of it. So inclusion of it, then how many different options are available. Let me check with 5. 5, can we add 2 into it? 7, let's say. Subarray. Can be consecutive but does not need maintain order. I mean, really, I don't know. Subarray, what? Subarray is a contiguous part of array. Subarray is an array that is inside another array. For example, 1 could be one subarray, 2 could be, 3 could be, 4 could be, 1, 2 could be, 2, 3 could be, 3, 4 could be, 1, 2, 3 could be, and 2, 3, 4 could be, and 1, 2, 3, 4 could be. So longest subarray means continuous subset of array. So 10, 5, it will be more than 15. That could be. Can we add more than a number to it? No. Then 5 to 7. Oh, that means it will be easy part. That means as compared to the earlier one, it will be easy. I was confused with finding a subset in any elements. So let me think about it. Then now it could be. Okay, let me change the color. I don't like black, at least here. In reality, like I like to wear black t-shirts, and Yeah, especially I really like black t-shirt and light blue jeans. It's my favorite combination for always. Okay, so we have these numbers. Now I'm just assuming. Let's start with 10. So 10, we have this number 10 plus 5. Okay, so we assume that this number could be, yeah, it would be. Now the thing is, if you will include these two numbers and then you wanted to add this number, you will see, okay, it is 15. So we have maximum subsequence like this one. So right now we don't have, we have till 15 we got, and count will be 2. But now we want to check another. So if we add, you can't add. That means we need to drop the last element and we need to check from the we need to check. So can I say 5 2? No, this won't help. Now can I say 5 to 7? 7 14? No, it won't. Then can I say this one? Yeah, it will. It will. Okay. Now we need like if we are adding another number, then it will increase. So can I drop the last number? Yes, drop the last number. And now check from this number till here. Can we have? So let's say 7 2 9 9 1 10. Okay, 7 3 10 19. So it's more than that. So can we drop the last number and say it like this: 7 1 9 1 8 8 9 17. So it's still greater than the number. That means we need to drop the last number, then only the numbers will be contiguous and we will be able to you can say check. Then it won't work. Then 9 1 10, and we can see the numbers. So far we have covered 9 1 10. It's not working. I mean, yeah, so we need to, and we are at the end of stage, so we cannot extend the numbers from the front side. So here we will start with this. I know we can't calculate again and again, so here we are going to do one more thing. The numbers sum will be 10 15, and 15 plus 2 17, and then 17 plus 7, this number, (24) 25, and 25 and 9 34. Like this the number will be. So we'll start from this number, from the first number we'll start. So I will be here and Z will be here, pointing to the same number. Start and end, you can say. Let's use okay 10. So we can say 10. Right now we have 7 sum of 10, so it's lesser than this. So let's move to the next number. So we'll move the end number. End will be here, and we can say start plus end. The sum is like here, if you see 10 15. So 15 is okay. Or even do we need to say, you can use without it, right? So can I say CS equals to this number? CS is 50. CS, when we are increasing the end, just need to increase the number. So CS plus equals to 10. Yeah, 5. Now we have, so initially start CS will be 10 and starting on 0. When will add the number next? 5. So 10 will change to 10 plus 5 15. Okay, 15 we have right now, and start is pointing to this and to pointing to this. So 15 matching with the k. So can we say end minus start plus 1, that will be the max will be length 2. Great. Now we just need to check, move to next number. So it's like 17. So we have 17. We added the number into is this one. 17 is greater than this. So we need to save start to the next number. That means it start will pointing to it, this start, end will pointing to this, and start will point to this. When we are moving start, so we need to delete the drop the number that we added. So minus 10. So 17 minus 10, it will be 7. So we have right now 7. So 7 won't work. Then it will move to next number and will be here. So 7 plus 7, 14. 14 will be there and start will be here. So yeah, so far we have count equals to 17, and now next 14. So let's move to the next number, then 15. So it is matching with the count. So can we say we will calculate the count and we'll do this. So the step will be, let me note down the algorithm for. So initially let's do one thing. Start equals to 0, end equals to 0, and count equals to 0. Okay, and then again we have one more variable, that will be and let's start with while end is less than n. Yeah, that means we are going to do it. So if okay, cs equals to, let's say, okay, cs will be, you can say, okay, so we initially it will be like cs will be end minus start. That means let's do one thing. cs equals to end plus, I mean, yeah, I mean, I'm literally missing something, some piece here. We'll start with first number. So start will be 0, end will be 0, count will be 0, and cs will be 0 at starting. Okay. No, cs will be 10. Now while end less than n, so we are in the first, you can say index, first index. It will be pointing to first index element. Okay, so it will point to first index. I just wanted to use it in a proper approach, you can say, without waste unnecessary jargons and all. So that's why I'm thinking to use some better approach, and it is taking little time. So 170, I am just assuming we'll finish it and we'll log off. I mean, just yeah. So it like we got the solution, just we need to use it in a proper way, so that we can make the write up, like we can use it in a proper way. Or you can say I need to write something, otherwise it will be like lots of boilerplate code, and that I don't want to use here, because it's simple problem. I can see I just need to formulate it, and Here I just wanted to do some best approach whatever is coming into my mind. So first thing is, it will be pointing to end, will be pointing here, start will be pointing here. So what will be the first conditions here we need to check? If cs greater than k, that means we need to drop this number, right? Okay, great. So what we will do, we need to move to next number. Greater than k, then start will be start plus equals to 1. That means it will move to next number, and end plus equals to 1, and cs will become cs minus you can say array of start. So let me just move this to this num place, so it won't be problem here. Yeah, so it will be here. Okay, let me just rewrite it in a proper way. So if cs is greater than, current sum is greater than the target value, that means we need to reduce the weight. And for that, my bad, I'm not sharing my screen. Okay, yeah, so that means cs is greater than k. It means that the value that is currently at the end, we need to down the weight, and the best way is to you just cs equals to cs minus you can say array of start. Okay, and now just move on, bro, from your problem. So start plus equals to 1. Just move to next step, and end will be plus equals to 1, and cs equals to array of end. So we just added, I mean, just when we are in this approach, we just move to next step. But the problem is, if we'll do this, the thing is, we need to check one more condition here. My bad, where is that? Oh, I forgot somewhere. Or what? Where is that solution? I need to search it. CS. Man. I just. Yeah, we are here. Great. Okay, so what we need to check when we are adding a number, it could be index overflow. So if ind is greater than less than n, then we need to add this. Okay, equals to k. Simply do one thing. CS means means count count equals to max of existing count, and you can say it will be end minus start plus 1, this one, and just we need to change end plus equals to 1, cs plus equals to array of end so just worried about it, like is it the right approach to do this? Like we are making a change in the next step, what if we just wanted to see. Yeah, let's solve it using this approach only. We'll figure out. That's not a. So let's use variables. Start equals to pointing to 0, end is pointing to 0, count equals to 0. So far we have count equals to 0, and CS will be 10. So we have right now current sum 10, while end less than, you can say, nums. Okay, let me use n. N is nothing but len of nums. So while end less than n, that means we can process these numbers. So if CS current sum is greater than k, that means we need to lose the weight. Okay, I missed one condition. That was if CS is less than k. So let me do it. First let me do CS greater than k, that means we need to remove. So weight, so CS is nothing but CS minus, you can say, the existing weight, CS of, I mean nums of start, you have to drop that weight. Great. And now what needs to be done, end will be start, no, end will be, we need to move progress end plus equals to 1, and start, sorry, so yeah, end is like we are we just advanced to the end, and we need to advance the value of plus equals to 1 start also. So these are the two things that we need to be done if it's this condition. So we just drop the CS, we advance this value, I'm just thinking, can we do it in a better way, like every time initially end will be pointing to 0, -1, let's say. Let's say in this 0, start is pointing to 0, end pointing to 0. So first what we'll do, CS plus equals to, that means we are adding the existing element, you can say array of, not nums of start, and I mean sorry, end, that means we are including the number. If CS is greater than the k, that means we need to drop that element, and advancing and will remove it, that means just we need to drop the element. So CS minus nums of start, we are dropping that element, and okay, CS will be this one, and start plus equals to 1, we have just advanced the start value of start. If elif CS equals to K, that means it is matching with the target, then we need to just do one thing. Okay, what needs to be done? That means count, you can say count equals to max of count, comma, star, not start, end minus start plus 1. That will be the value that we need to that is going to give the length, max length of existing matching condition. And do we need to do anything with the start? No. Do we need to make any change to end? No. It will be taken care by else. Else means it is smaller than this value. So what needs to be done here? Simply we don't need to take care of anything, because these are the two conditions only. Otherwise it's like we just added the number, so we do not need to make any change. And finally we just need to do int plus equals to 1. And I think this is the right approach to approach the problem, and I was thinking about it, but I was not getting the right solution. I mean, yeah, so finally we get it, and I hope now we will be able to finish it quickly. Return nums of, okay, return max count. Okay, I think I'm just missing something here. No, we are not missing anything. So CNT, that will be the maximum value. Nums of end. What is the wrong with it? Did I made any mistake? Why it was not working? Let me see. I think I missed something. I think there was separate or what? Oh my god, it failed. Something went wrong. I what? It passed 5 out of 124 cases. I believe we need to change it to this number. Positive, then this will be working. Try, let me see it. What went wrong? With 30, then we are going to add minus 30, so it will add 534. It will see like if numbers can be grouped together and the number when we are subtracting or I mean, yeah, something is missing here. The problem is we have negative numbers, and suppose, let me dry run it. I've never thought about it, bro. Mistake. Minus 38 and 534. What is our target? 204. I don't know if I'll be able to 848 minus 223 and minus 762. I don't know. It won't work. So if the number is positive, so first you took this number. If it is smaller, then you took this number and you added both, and you saw it's greater number. That means you just dropped this number. So when you are dropping, there could be two scenarios. Okay, absolute won't work here. So negative numbers, then that means if nums of start greater than 0, then CS equals to CS minus nums of start. That means this number is going to be subtracted. Else, that means if the number is greater than equals to 0, let's say. Otherwise, we are going to do one more thing, that will be CS and CS, and that means we just added that number, and now we need to subtract that number. I mean, when we are doing minus operation, minus plus this one, CS and plus we need to add that number, absolute of nums of start, so that whatever the number that we just added and our just subtracted, that will be counter. Okay, so that's how we are going to approach it, and now I hope it will run perfectly. Still same issue. What is the problem, bro? Honestly, this will be number, and after that we added 534. So if you see, if both the sum of both is smaller, if it is larger, that means based on these two numbers we can't make value. But what if we are getting a number in future that will be positive negative number? Then we can make them, right? We can make a pair, and there will be, I mean, it's not working really. The approach is completely vague that I've used. Enough, was not expecting this. we need contiguous array. So let's say 38, why we have 534, 204, minus 848, and minus 2, 2, 3, and then minus 762. These are the numbers. We'll start with these two. Can I say? Initially, these two numbers are there, and when we'll sum these two, then we'll get something like 4, 496, 496. I believe, yeah, 496. That's big number, and we are expecting minus. Okay, 1066. So logically, what's going to do? It will do like, okay, it's a big number, then let me reduce the last number, and it will assume everything will be working, but it won't work. But what if we have a number that is bigger number than this, and we are adding, and it could make a positive value as a feasible. That's where my approach failed. Okay, bro, your approach is not working. Now suppose if we added this number, then it might work. If all the numbers are positive, then that one will work. But here it's a blend of negative and positive numbers, so we cannot guarantee. Not working. Let me see if I just saw there, why use a hash map for prefix sum. So can we do something with prefix sum? So minus 534, so it will be minus 38, and it will be 496. And suppose we got, then we get 496 plus 2, 42. Let me ask ChatGPT to calculate it. Why would I? Five 204, 884, 2323, 762, 767, 277, minus 717. Wow. Okay, so it's doing like this: 496, 700, and then we have minus 148, then we have minus 371, then minus 1133, then we have 366 minus, then we have, okay, minus 89, and finally minus 806. So these are the numbers, you can say. Now the thing is, how can we do this? Can we utilize this? So yeah, we know we can take only contiguous number. So can we make a decision whether we can consider this number? Okay, now let me say like this. Initially we have 38. So is there any number anywhere where I'll be getting, if I'm including this number? So we are not getting somewhere. Now just we need to drop this number and say, can we get anywhere where, is there any number where we are getting this number? If so, then that is okay. If not, then that means we can discard this number. Now the same will happen with this number. Okay, that means, so that means we are discarding the 496 from the numbers. So if we are discarding this number 496 from existing numbers, can we get the number? Same with this number, same with this number, same with this number, this number, this number, this number, this number. So if we'll add into hash map, and then we'll start looking for each number and their corresponding. First we'll check, like we'll just check if there is any number that is matching with this. If matching, then we'll consider that as a, okay. So if we get any number, that means till there we have. If so, if not, then we'll start looking from this number. And well, I feel like, yeah, let's see. I hope we can do it. 38,496. Okay, so let me first calculate the prefixum. And let me store them in the map as well as map. So map, let's see, no, let me say HM will be dict. For IDX and EL in, okay, enumerate nums. So we got it now. So every time we are going to let's say CS equals to 0 initially. Now we are going to CS plus equals to EL. So we added element, and now just we need to add it into dictionary. So what will be the key? Key will be CS. Okay, so HM of CS, if it is in this key, then what is the value of it index? Great. Yeah, now that's all. CS plus equals to EL, and that will be the mapping. And yeah, let me add it into a dictionary. Shall we let's say array of this yes. So PS prefixum, that will be nothing but, you can say CS ps dot append cs. Great, so we did this. Now let's start mapping. Let's start from first element. So first element, so idx and el in enumerate, you can say ps so first look for any element and prefixum matching the existing, okay, you can say matching the target. So if you can say dict, no, if k in ps means it is there, not prefixum, you can say has map. Yeah, so why you added 2 times cs, current sum we already have. And let's drop these ideas of doing this. So count we don't need, and even let me drop this complete solution here. This is applicable to, let me keep it as it is. Okay, idxcl, and now we are enumerating numbers. I mean, really I'm doing something that it's crazy. I mean crazy in the sense I have to write it first, that but here I'm thinking that's the mistake I'm always doing. And so first we got this number k in hm, that means if the key is available in hash map, that means then there is a number. So count will be nothing but, you can say, but there could be more than one, right? Yes, it's possible. So let's say for k in keys, hm dot keys, and if k equals to you can say no, we can't use k, at least for here. Key in keys, so k equals to key, that means it is there. And so count equals to max of count, and you can say existing count, and then you can say value of key. So hm of key, that means where the value that we are getting there, it's something but the number of elements till there. So we have if you remember, we added the index, so that means it will be 1 plus. So okay, so this is the case for initially. Now just we need to drop a number and need to check if we can get the value. So idx and element, so we are getting an element. Now we need to drop this element and we need to check. And every time when we are dropping, we need to check, I mean we need to iterate through all the elements, because I mean really is it okay? No, but there will be only one key, right? We are expecting only one, and if there is one, I mean it will override the largest one. Okay, correct. So we do not need this. I am not assuming that there will be. So let me drop this for the timing at least. Let's see. Okay, my bad. For key, if key k in hm, so we are just going to eliminate through all the elements, and let's see if el minus if you can say the existing element. if okay, so if the number is negative, that means we need to drop it. I mean, just we need to add it. No, I mean, if we add, that means at the time when we are adding, it reduced the number, so now it will increase the number. So when we'll use minus, then it will be plus, and when will we use plus, then it will be 2. So if okay, so you can say PS, that means the final sum, prefix PS of -1 plus I mean, we are just deleting the numbers, right? That means it will be adding if it's paused. So if that is the EL in HM, that means if this key is available in the HM, then you can say HM count is max of CND and HM minus HM of, let me say it, key equals to this one, so it will be easy and we do not need to calculate it more than once. So key in, I'm really sorry for this. Okay, so we have these two numbers, and now we can compare HM of key. If key is there, that means HM of key minus, we need to change the IDX and we need to add one number, because when we are subtracting, we are targeting, for example, there is n is 2, 1 minus 0, 1. There will be index of n minus 1 and n minus 1. You can say minus 0 will be n minus 1, but we want 1. So count will be this, and now finally return the count. Let me see if we can work. It can work. Otherwise, I'm going to watch the tutorial. You can say. Oh. Okay, it's pretty horrible. I'm getting 1. Why 0? So I mean, literally it's not working. Use a hash map to store the prefix sum of array. This helps efficiently track subarrays that sum to k. And second, for each index I calculate the prefix sum up to that point. If the prefix sum minus k exists in the hash map, the subarray between those indices sums to k. Note that this approach is only valid for positive number as per post. Okay, positive, I know. Positive plus negative. Bro, I really feel bad for me. Prefix sum to solve the problem of finding the longest subarray with the sum equals to k. The prefix sum of array is ending at index I, simply the sum of all the elements of subarray. By keeping the track of these prefix, first we will declare a map to store the prefix sum and their corresponding indices. We will run a loop from 0 to n minus 1, where n is the size of array. For each index I, add the current element to the prefix sum. If the prefix sum equals to k. Consider the length of the if the remaining sum exists in the map, calculate the length of sub-array ending है. If CS plus equals to element, that means we added element, and CS and literally anytime I'm unable to solve it. What's I'm doing? It's like I'm just busy solving something bad way. I need to practice more. Or what? Something went wrong. Let me start it tomorrow. I mean, I just solved one problem, and that also with the help of solution. I feel bad, very bad. So let me start it tomorrow. I'll finish it. I need to practice more. Feeling bad. Literally, things are not going in the. Stop streaming. Let me stop it. Thank you guys. Bye bye.